Welcome back to Cosmic Discovery. Today we're exploring the vibrant tapestry of the universe, a story written in starlight and shadow. These are the top 10 cosmic phenomena that shaped our understanding of the universe.
"70,000 years. This intricate that red star.
This is the culmination of Project Stardust, the cosmic cage.
The energy readings are off the charts, Captain.
And the new fleet is ready for deep space.
Billions of stars, yet we focus on a single planet. Is that ignorance or simply fear of the unknown? But is this glowing vessel truly the salvation they seek, or just a misguided hope in the vast cosmic ocean?
It is the cosmic speed limit, 299,792 meters per second. A boundary.
A light year isn't a measure of time, but of distance. It's how far a beam of light travels in a single year across the vacuum of space.
We treat it as a unit of distance, a convenient shorthand for astronomers to map the cosmos.
Literally. While this photon struggles, let's look at Proxima Centauri. It's a tiny red dwarf compared to our
At the farthest reaches of the sun's influence, we find the Oort Cloud, a magnificent
Imagine constructing a gargantuan generation ship, a floating city in the void, packed with a hopeful human crew. Years, that's 70 millennia. Just try to wrap your head around the powerful force scale of that timeline. All of recorded human history, from the first wheel in Mesopotamia to the atomic age, is a mere 5,000 years. On a voyage to Proxima Centauri, you'd need that entire epic of human existence to repeat itself 14 times over before you even catch a glimpse of your destination.
Entire generations would be born, live out their full lives, and pass away within the hum of a metal corridor.
Reducing our entire planet to a mythological story told to children who have never seen dirt. The original crew would be ancient, forgotten ancestors to the people who eventually arrived.
You feel an immediate, profound connection to the cosmos. You perceive a vast, static ceiling of brilliant lights.
You think you are looking at the universe exactly as it exists in this very second.
Light requires time to cross the vacuum of space. The speed of light is fast, but space is so unimaginably vast that light is reduced to an agonizing crawl. When you look at Sirius, the brightest star in the night sky,
If the inventor White Light Connect Your Retina left that star 8.6 years ago, you are not seeing Sirius as it is.
you are seeing a photograph of Sirius taken nearly a decade in the past. It's a ghostly, faded illusion. When you locate Betelgeuse, the titanic red supergiant glowing ominously in Orion, you're looking at light from over 6 centuries ago. You are not observing the universe, you are watching a delayed broadcast. Many structures we see no longer exist.
Stars run out of nuclear fuel. They reach the end of their lifespans and detonate in colossal supernovas.
Fall, but the news of their intense dramatic moment has not reached us yet. The light is still crawling across space. They act as cosmic archaeologists, analyzing phantoms.
The universe we see is a projection of a past that's already been erased.
Its mandate: photograph the gas giants, then keep flying into the absolute dark, pushing beyond the reach of our sun.
It carries a golden record encoded with the sounds of Earth. A lonely greeting.
It has been traveling continuously, without a single moment of rest, for 47 years. A tiny pioneer in the dark.
Voyager 1 is a speed dark creature. Call out through the void at 61,000 kilometers per hour. That's fast enough to cross Earth in minutes.
It conquered the termination shock and passed the heliopause, finally leaving the sun's direct magnetic influence behind.
It officially breached the magnetic bubble, becoming the first human-made object to ever taste the true interstellar space.
But let's put that epic journey into perspective. Against the backdrop of a single light year, the math is absolutely soul-powerful force.
After nearly 50 years of relentless flight, Voyager 1 has covered only 22 light hours.
It hasn't even reached the Oort Cloud, a theoretical shell of icy debris that marks the true gravitational edge of our home.
This cosmic parking lot is so far away that Voyager 1 needs another 300 years just to reach the front gate.
3 centuries of silent coasting through the pitch black, just to arrive at the beginning of that vast, frozen field.
Light needs time to cross space. Though fast, space is so vast, light's journey becomes an agonizing crawl.
Sirius's light left 8.6 years ago. You see a cosmic photograph, nearly a decade old. Betelgeuse, Orion's red supergiant, sends light traveling through freezing, irradiated space for over 6 centuries. You're not observing the universe, you're watching a delayed broadcast. Many magnificent structures enchanting astronomers no longer exist.
Stars exhaust their fuel, losing their gravitational epic confrontation. They detonate in colossal supernovas, ending their brilliant lives. Intense energy bursts outshine galaxies, cores collapse into neutron stars or black holes. They fall. News of their demise hasn't reached us.
Their intense ENS light still crawls across the universe, millennia from our lenses.
They're cosmic archaeologists analyzing phantoms. Our universe is a past projection.
For 47 relentless years, Voyager 1 has journeyed continuously, without a single moment of rest. An incredible feat. It hurtles through the void at an astonishing 61,000 kilometers per hour, a testament to human ingenuity.
It bravely crossed the termination shock, then ventured beyond the heliopause, pushing boundaries.
It officially breached our sun's magnetic bubble, boldly entering the vast, uncharted expanse of interstellar space.
This is it, the furthest any human-made artifact has ever ventured into the cosmic unknown. But let's put its journey into perspective. How does its progress compare to a single light year?
After almost half a century of blistering, relentless flight, fast enough to cross Earth in mere minutes.
Voyager 1 has only covered a total distance of roughly 22 light hours. Just light hours. Back in 1977, we launched Voyager 1. It was our boldest, most hopeful leap into the great unknown. For 47 years, it hasn't stopped. Not for a second. It's been a relentless, lonely sprint through the dark. Its call out along at 61,000 kilometers per hour. That's fast enough to cross the entire Earth in minutes.
Ahead lies the Oort Cloud, a massive, frozen graveyard of icy debris and comets, marking our solar system's true edge. Even at its blistering speed, Voyager needs another 3 centuries just to knock on the door of that ice field.
To actually cross it, that's a 30,000-year journey. 30 millennia of silent coasting through a field of fallen ice. Our most legendary explorer hasn't even reached the end of our cosmic driveway. We're still locked in our own backyard.
Haunted by the chilling silence, we call out radio signals into the void, desperate to hear a single voice back. You look across the room, believing you see objects and people exactly as they exist right now, in this exact nanosecond.
Human intuition relies on the concept of a shared now. Physics ruthlessly dictates otherwise.
Light takes time to reach your retina. You never see anything as it is, only as it was. Look at the moon, our closest celestial body. You're seeing a 1.3-second-old projection. If the moon cracked in half, you'd stare at a perfect sphere for 1.3 seconds before reality updated.
Look at the sun. It dictates all life on Earth. But you are seeing an 8-minute, 20-second-old ghost. If the sun vanished instantly, Earth would be completely fine for over 8 minutes.
Then, the gravitational tether would snap and eternal darkness would connect. The universe fractures completely. Our greatest triumph of exploration, the golden small figure of human spaceflight, has not even scratched the surface of our own driveway.
We celebrate reaching interstellar space, but we are still locked tightly in the basement of our own solar system.
Number 7. The communication wall. Driven by the chilling silence of the cosmos, we beam radio signals deep into the dark.
But the speed of light guarantees that interstellar diplomacy is not just difficult, it is mathematically impossible.
The Milky Way galaxy, our home, is approximately 100,000 light-years across. Radio waves are a form of electromagnetic radiation.
Imagine finding a super-advanced, peaceful alien world on the far side of our galaxy. A cosmic neighbor, yet so far. We send a focused radio burst, a simple, "Hello, we are here," aimed directly at their distant home. That message would travel for 100,000 years before reaching them. A century of millennia just to say hi.
They'd have to catch that tiny, faint whisper hidden in the massive roar of the galaxy's background radio.
If they decode our primitive tongue and instantly fire a reply back to our exact spot in space.
We'd wait another 100,000 years for their answer. A total of 200,000 years for one simple greeting.
200,000 years ago, our ancestors were just starting to use basic stone tools in the African savannas.
We hadn't even mastered fire yet. That's the powerful force scale of time the universe demands for a conversation.
By the time an alien reply reaches Earth, the human civilization that sent the original greeting will be completely unrecognizable. We will have evolved into a new species entirely, transcended biology, or, far more likely, based on the Fermi Paradox, gone completely extinct.
Wiping ourselves out through conflict, resource depletion, or cosmic accident. The silence of the stars is a warning.
Even if the galaxy is teeming with millions of vibrant, intelligent civilizations, physics enforces a strict, permanent quarantine. Everyone call out into the void at once. But because of light's unyielding speed, no one will ever hear the answer in time.
Number 6. You are always looking into the past.
You look across the room and believe you are seeing objects and people exactly as they exist right now.
In this exact nanosecond, human intuition relies on a shared now. Physics ruthlessly dictates otherwise. We are trapped in time.
200,000 years ago, our ancestors were just starting to chip away at stones in the African savanna. Talk about a slow start.
No fire, no farming, no a video app. Just us, some rocks, and a whole lot of confusion about how the world worked. We were prey back then. By the time an alien says hello back, the humanity that sent the message will be long gone. We might be cyborgs, or ghosts, or just plain extinct. The Fermi Paradox suggests we probably won't even be around to listen. Conflict, hunger, or a stray asteroid could wipe us out. Our cosmic greeting might just be a message from a fallen world.
Even if the galaxy is full of life, physics keeps us in a permanent cosmic timeout. No talking to the neighbors allowed.
We're all shouting into the dark at once, but light is too slow. We'll never hear the reply before the lights go out.
Number 6. You are always looking into the past. We think now is the same for everyone, but physics has other plans. Even if the galaxy is teeming with millions of vibrant civilizations, physics enforces a strict, permanent quarantine. We are all isolated. Everyone is called out into the void simultaneously, but light speed ensures no one will ever hear an answer in time. It's a silent cosmic cage.
Number 6. You are always looking into the past. We assume now is a universal constant, but that's just a comforting illusion. You think you see the world in real time, but every photon connect your eye is a message from a moment that has already passed.
Human intuition relies on a shared now. Physics ruthlessly dictates otherwise. Time is a fragmented mirror, reflecting only what was.
Because light takes time to travel, you never see anything as it is. You only ever see the ghosts of the past.
Look at the moon, our closest neighbor. You're seeing a 1.3-second-old projection. Even at this distance, time creates a lag.
If the moon cracked in half right now, you'd see a perfect sphere for over a second. Reality takes time to reach you. Radio waves obey the speed limit. A signal crossing our galaxy takes 100,000 years. That's a long wait for a hello. If we pinged an alien civilization on the far side, they'd get it in 100 millennia. Assuming they're even listening. A round trip? 200,000 years. That's longer than modern humans have even existed on this tiny blue rock. 200,000 years ago, we were just mastering stone tools. We hadn't even figured out fire yet. Talk about a laggy chat.
By the time a reply connect Earth, we'll be unrecognizable or extinct. The Fermi Paradox suggests the latter is quite likely.
We assume now is universal. It's not. It's a biological filter. You never see the present, only the ghostly past.
Look at the moon. You're seeing it as it was 1.3 seconds ago. If it vanished, you'd still see it.
The sun? That's an 8-minute-old ghost. If it went dark, we'd have 8 minutes of blissful, ignorant sunshine left.
Look at the sun. It dictates all life on Earth. But you are seeing an 8-minute and 20-second-old ghost. If the sun vanished instantly, winking out of existence, Earth would be completely fine for over 8 minutes.
We would orbit an empty, fallen patch of space, bathed in non-existent light.
Scale this unnerving reality up, and the concept of the universe fractures completely.
Find the Andromeda Galaxy in the northern hemisphere on a clear night. It appears as a faint, fuzzy smudge against the blackness.
It is our closest major galactic neighbor, a sprawling spiral of 1 trillion stars hurtling toward us.
The light striking your optic nerve from Andromeda tonight began its journey 2.5 million years ago.
It was emitted when early hominids, like Homo habilis, were just learning to walk upright and use tools.
As human history unfolded, through ice ages and fallen empires, that ancient light silently crossed the immense void between galaxies.
The now we perceive is an illusion, a trick of evolution. We believe we see things as they are, in this very nanosecond.
Human intuition craves a shared now, but physics dictates otherwise. Light takes time to reach us, so we only ever see things as they were.
Look at the moon, our closest neighbor. You see a 1.3-second-old projection. If it cracked now, you'd still see it whole for 1.3 seconds. If the moon cracked, you'd see it whole for 1.3 seconds. Now, look at the sun. You see an 8-minute and 20-second-old ghost.
If the sun vanished, Earth would be fine for 8 minutes. We'd orbit a fallen patch of space, bathed in non-existent light, until darkness connect.
Scale this unnerving reality up, and the universe fractures. Find Andromeda Galaxy on a clear night.
Andromeda, our closest galactic neighbor, 1 trillion stars hurtling toward us.
The light connect your eye tonight began.
Number 4, the infinite mass problem. So forget warp drives, forget exotic matter and space-time manipulation.
Harnessing antimatter annihilation, nuclear fusion, or even black hole accretion disks. Accelerate it continuously.
Until we connect 99% the speed of light, Einstein's special relativity introduces a devastating mechanical penalty for extreme velocity. It is a cosmic speed bump designed to break your ship. As an object moves faster through space, its kinetic energy increases. Because energy and mass are interchangeable, E(m)c2, an object's mass increases relative to a stationary observer. At normal terrestrial speeds, this mass increase is so microscopic, it goes completely unnoticed. But relativity is non-linear. Push a spacecraft to 90% the speed of light, and its mass more than doubles. The speed of light cages us. So, physicists seek a loophole, turning to math to pick the lock of the cosmos. The trick isn't pushing a ship faster than light. That's illegal. Instead, you manipulate space itself. Compress space-time ahead, expand it behind. The ship sits still in a warp bubble. Space moves around it, not the vessel. The bubble serves distorted reality, faster than light. Math works, physics are sound. On paper, the universe allows it. We had the blueprint for the stars, but energy calculations revealed a problem. Bending space-time around a vessel needs, but not just normal energy. You need negative energy, specifically exotic matter with negative mass, equivalent to Jupiter's total mass. Negative mass is theoretical, never observed. It defies the standard model of physics. It likely doesn't exist. In 1994, physicist Miguel Alcubierre published a paper. He proved faster-than-light travel is mathematically permitted by Einstein's general... The trick? Don't push a ship faster than light through space. That's illegal. Instead, you manipulate space itself. Compress space-time in front of the ship, then rapidly expand it behind. It's like surfing a cosmic wave. The spacecraft sits stationary inside a warp bubble. It doesn't move. Space moves around it, surfing a distorted reality faster than light. Math works. The physics are sound. On paper, the universe allows it. We finally had the blueprint for the stars.
Then call the energy calculations. Bending space-time around a vessel requires an incomprehensible amount of energy.
But not just normal energy. You need negative energy, exotic matter with negative mass, equivalent to the entire planet Jupiter.
Negative mass is theoretical, never observed. It defies physics and likely doesn't exist anywhere in our universe. This concept completely defies the standard model of physics. It likely doesn't exist anywhere in our universe. Even if it did exist, harvesting a Jupiter-sized sphere of negative mass, stabilizing it, and integrating it into a spacecraft engine is an absolute functional impossibility for any biological species. A truly disheartening reality. The universe is endlessly cruel. It dangles the keys to galactic travel right in front of our faces, just out of reach. But then it categorically refuses to stock the building materials required to actually construct it. A cosmic joke. It is a calculated, mocking fallen end. A mathematical wall we can never breach. So forget warp drives, forget exotic matter and space-time manipulation. What if we just rely on brute, unadulterated force?
First, we draw the basic shape, add the limbs, and look, it comes to life. Hi there!
It provides the exact, flawless mathematical blueprint for our escape, then mocks our inability to build it. It categorically refuses to stock the building materials required to actually construct it. A calculated, mocking fallen end.
Number 4, the infinite mass problem. Forget warp drives and exotic matter. Let's try brute force.
What if we build the most powerful conventional engine ever conceived? A true creature of engineering.
We could harness antimatter annihilation, nuclear fusion, or even black hole accretion disks for power. Strap it to a heavily shielded ship and accelerate continuously until we connect 99% light speed. But Einstein's special relativity introduces a devastating mechanical penalty for such extreme velocity. A cosmic speed bump.